singular linear transformation. Let T mapping from V to W be a linear transformation. T is said to be singular linear transformation if there exists a non-zero vector V in capital V, that is, there exists a non-zero vector belonging to the vector space V such that TV is equals to 0. Now if the vector is non-zero, then obviously kernel will be non-zero, na? When kernel is not equal to 0, then nullity is not equal to 0. So nullity of T will be greater than equal to 1. This means that T is not 1 1. So a transformation is singular if it is not 1 1. Non-singular linear transformation. Let T mapping from V to W be a linear transformation. Then T is said to be non-singular linear transformation if TV is equals to 0 implies V is equals to 0. This is the condition for kernel T, na? It means that kernel of T is 0. If kernel of T is 0, then nullity is 0. If nullity is 0 means T is 1 1. And by rank nullity theorem, rank of T plus nullity of T is equals to dimension of V. As nullity of T is 0, so rank of T is equals to dimension of V. Now next we are discussing linear transformation and matrices. Let T mapping from V to W, they are over field F only, be a linear transformation. Let dimension of vector space V be n and dimension of vector space W be m, and V1 be the basis of V1, V2, so on till Vn, because dimension of vector space V is n. This is basis of V. You can also say that it is ordered basis of V. V2 will be basis for W. Or you can say ordered basis of W. Now my target is to find the matrix representation of T with respect to bases V1 and V2. This is the notation for matrix representation of T with respect to bases V1 and V2. Now TV1 can be written as linear combination of elements of these bases because T is a mapping from vector space V to W. Similarly, TV2 so on till TVN alpha 1n W1 plus alpha 2n W2 so on till alpha mn Wm. So coefficient matrix will be alpha 11 alpha 12 so on till alpha 1n, then alpha 21 alpha 22 so on till alpha 2n. Means in the first column image of V1 is there, in the second column image of TV2 is there, and in the last column image of TVN. This was matrix representation. Coefficient matrix will be simply this one. Alpha 11, alpha 21, so on till alpha m1, alpha 12, alpha 22, so on till alpha m2, alpha 1n, alpha 2n, alpha mn. Means matrix representation of V1 with respect to basis V2 is the transpose of this coefficient matrix. Matrix representation is clear?
Yes, ma'am.
Okay. Now I'm discussing some examples. It will be more clear. Let T mapping from R cube to R square be a linear transformation defined as Txyz is equals to 3x minus 5y, 5z minus 4x. V1 is standard basis with respect to R cube. Means 1 0 0 0 1 0 0 0 1 basis of R cube. V2 1 0 0 1 basis of R square. Now I need to find matrix representation of V1 to V2. Now I am giving random options 2 cross 2, 3 cross 3, 2 cross 3, 3 cross 2. So firstly, matrix representation order of matrix of that matrix representation is 2 cross 3, means codomain and then domain, means 2 cross 3. There will be 2 rows and 3 columns. Means option A, B and D are discarded. Option C will be correct. Now let us see what will be the representation. Simply you need to put these basis elements in this given transformation. T1000, this is 3 minus 4. T010, this will be minus 5, 0, and T001, 0, 5. Now you need to represent this ordered pair in terms of this basis B2, basis of R square, means 1 0 plus 0 1. Here also so this will be 3 and this will be minus 4, minus 5, 0, 0, sorry, 0 and 5. So matrix representation will be 3 minus 5, 0. Whatever coefficients of 1 0 is there, write them as in terms of row and minus 4 0 5. Is this clear how to write matrix representation?
Yes, ma'am.
Okay. Now there is small trick. Whenever you are given any linear transformation and you need to write the matrix representation of B1 with respect to B2, then how you can write it? Simply put the coefficients of x here, then y here, and then z here. This trick can only be applied when standard bases are given. For example, this one only, this was standard basis, na? Standard basis of r cube and standard basis of r square. So no need to do this part. Means you no need to think of these coefficients of this 1 0 and 0 1. You can directly write from here only. Or one more thing, I have told in the trick that matrix representation of B1 and B2 means coefficients of x, y, z. Coefficient of x is 3 and minus 4. Sorry. And here coefficient of y is minus 5 and 0 and z 0 and 5. Trick is clear?
Yes, ma'am.
Okay. Another example, B1 is equals to 1 0 0 0 1 0 0 0 1. This is basis of R cube. One two two one. Basis of R square. Find the matrix representation of B1 with respect to B2. Try this once. After that, I will discuss.
For the same transformation? 3x minus 5y 5z minus 4x.
Transformation is same.
None of these आएगा इसका.
पहले तो ये 2 × 3 होगा, so option A will be discarded, and then T1 0 0. This will be 3 minus 4 T 3 minus 4 means 3. You need to think the coefficients of 1 2 and 2 1, है ना? So whenever options are given, no need to think of the coefficients. Just simply put this first column in this 1 and minus 2. If it will satisfy 3 comma minus 4, then this will be a matrix representation, and then check the other also. T0 T0 1 0 T0 0 1 1 into minus 2, so this will be minus 3, no? So obviously here it was 3, it is not satisfying, so option B is also discarded. Let us check the next also. 1 2 and then 2 1 5 4. Obviously it will not satisfy, so C option is also discarded. Whenever options are given, then you can use the options. So answer is option D. एक सेकंड रुकना. Now I am discussing one December 2018 question. part C. Let C equal to 1 to 2 1 be a basis of R square and T mapping from R square to R square be defined by Txy x plus y x minus 2y if Tc represents the matrix of T with respect to the basis C, then which among the following is true? Here also we need to find the matrix representation. Options are
फर्स्ट ऑप्शन नो अच्छा अच्छा फर्स्ट जस्ट ये नीचे वाला भी सी में भी -3 3 लिखा हुआ है ना
सी में भी यही है, सी में भी यही, हाँ -3
So C option.
हम्म T12, this will be 3 1 -4 -3, and it is to be written in the form of 1 2 and 2 1. So if I put through options only, -3 and 3, -3 plus 6 3, -6 plus 3, so -3, this is being satisfied. So first column is correct, so option B and D will be discarded from here. Now let us check another one. T21, 3 1 minus T, 2 minus 2 0, 1 2 and 2 1. So if you will put -2 and 1, then it will be 0, so obviously A part will be discarded. So C part is -1 and 2. 4 minus 1 3, -2 plus 2 0. So answer is option C. So one more thing here, here only one basis was defined na, for R square. So you need to take this space is only for both codomain and domain. Okay, whenever only single basis is defined. Now a small trick. T is a mapping from a vector space to another vector space B, linear operator, and basis is B. And here basis is B dash. So from here I will get a matrix representation M, और यहाँ से भी एक matrix representation मिलेगी M dash. So they will be similar, means M is similar to M dash. Now what does it mean? That trace, determinant, rank will be same. T is a mapping from a 2 cross 2 matrix whose entries are real. Then we need to find the matrix representation with respect to this B. First of all, what will be the order of this matrix representation? Hmm?
2 cross 2.
Mm-hmm.
Good.
4 cross 4, na? 4 cross 4. I have told it's we have discussed this dimension, na? In the starting
Mm-hmm.
of basis and
Yes.
dimension. So 4 cross 4. And what is the standard basis of a 2 cross 2 matrix?
It
1.
is 1 0 0 0, then 0 1 0 0, then 0 0 1 0, 0 0 0.
Hmm. So I can take A as a matrix because it is not defined. So x, y, z, w. It is given as A into B. So x, y, z, w. B was 1025. So this will be on multiplying x 2x plus 5y z 2z plus 5w. Okay. और टू टेक दिस इजी मतलब इसको थोड़ा सा इजी मैनर में लिखने के लिए आई कैन राइट इट एज टी एक्स वाई जेड डब्ल्यू इज इक्वल्स टू एक्स 2x plus 5y z 2z plus 5w. And I have told you the trick that whenever bases are standard, then I can directly write the matrix representation. So in the first column, coefficients of x will come, then coefficients of y, then coefficients of z, then coefficients of w. So what will be the first column? Tell me. 1, 2, 0, 0. Then coefficients of y 0, 5, 0, 0. Coefficients of z 0, 0, 1, 2. And lastly coefficients of w. This is a 4 cross 4 matrix. Next. So you need to find matrix representation. What will be the order of matrix representation here? Tell me.
It will be 4 cross 4.
Now simply px is 1. So put px1, then x squared, then x cube. P1. Derivative of 1, 0. Px, derivative of x, 1. 3x square. So this can be written in the linear combination of these terms, the elements of basis. So matrix representation will be 0, 0, 0, 0, then 1, 0, 0, 0, 0, 2, 0, 0, 0, 0, 0, 0, 0, 3, 0. Is this clear?
Yes, ma'am.
Okay, now try one question and tell me its matrix representation.
It is 0, 0, 0. First column is all 0. Second column is all 0. Third column is G2, 0, 0. And then 0, 6, 0, 0.
T1 will be 0. Tx will be 0. Tx square will be 2. Tx cube will be 6x. So 0, 0, 0, 0, 0, 0, 0, 0, 2, 0, 0, 0, and then 0, 6, 0, 0. Try another question. I think now you can do it directly now, because you have computed matrix representation for this p dash x transformation and p double dash x. So you can add both the transformations. Sorry, matrix representations.
It is first column is 0. And then in second column, first is 6. Third column, 10, 12, then 0, 0. And fourth column, 0, 30, 18, 0.
So in this question, this was the transformation defined like this. And basis for P2 was given as standard basis only 1x x square. Basis for P3 was given as 1x x square x cube. And you need to find the matrix representation. The options were
is option B.
First, you can see that order will be 4 cross 3. So option A and C will be discarded. So T1, this will be 0 to x 1 dt plus 0. So this is x. Then Tx 0 to x t dt plus 1. So this will be 1 plus x square by 2. Then Tx square 0 to x t square dt plus 2x. X cube by 3 plus 2 and Tx cube 0 to x t cube dt. 1x x square तक ही लेना ना. So this will be 0 into 1 plus 1 into x plus 0 into x square plus 0 into x cube. 1 into 1 plus 0 into x plus 1 by 2 into x square plus 0 into x cube. 0 into 1 plus 2 into x plus 0 into x square plus 1 by 3 into x cube. So this is 0 1 0 0 1 0 1 by 2 0 0 2 0 1 by 3. The answer is option B. So here P was a vector space of dimension 3 over R. T was a linear transformation given by the matrix A 1 1 minus 2 minus 1 minus 4 5 0 3 minus 3 with respect to an ordered basis v1 v2 v3 of P. Then which of the following statements is true? Option A, T v3 is 0.
C option.
रीजन
मैंने तो जस्ट गेस किया है कि सम ऑफ द वेक्टर्स इज 0. Like first of sum is 0, second of sum is 0, third is sum is 0. Taking V1, first column as V1, second as V2, and third as V3. Actually कैसे करेंगे मुझे क्लियर नहीं है ये.
Or you can think like this, that V is a vector space of dimension 3 over R. Hint was here only. You can take V as R cube.
Yes.
Its dimension is 3, so you can use the standard basis for this. Means V1 as 1 0 0. हाँ.
Okay. But if we use, I was trying that only, but उसमें फिर मैट्रिक्स का क्या रोल है यहाँ पे A वाली? That is V to V linear transformation है ना, उसका A के साथ तो कोई रिलेशनशिप दिया ही नहीं है.
मतलब ऐसे कह रहे हैं कि जो टी लीनियर ट्रांसफॉर्मेशन दी गई है ना, इस बार उसने इस तरीके से टी एक्स वाई जेड समथिंग करके देने की जगह मैट्रिक्स फॉर्म में दे दिया. आप इसको भी कन्वर्ट कर सकते हो. दिस विल बी एक्स माइनस वाई एक्स माइनस 4y प्लस 3z माइनस 2x प्लस 5y माइनस 3z. ऐसे भी हो गया. So tv1. So what will be tv1? Means t1 0 0. So this will be 1 1 minus 2. From here also you can see that first column is there, and from here also if you put x as 1, y as 0 and z as 0, you will get the same thing. tv3 is t0 0 1 0 3 minus 3. So first option is saying that tv3 is 0. No, it is not so. Option A is discarded. Option B is saying that tv1 plus v2. tv1 plus v2. As it is a linear transformation, it can be written as tv1 plus tv2. 1 1 minus 2 plus minus 1 minus 4 5. Clearly it is not equal to 0 0 0 no? Option B is also discarded. Option C is saying tv1 plus v2 plus v3. tv1 plus tv2 plus tv3. मतलब आपका गैस ठीक था, बट एक करेक्ट अप्रोच पता होनी जरूरी है. मतलब कभी कभी गैस रॉन्ग भी हो सकता है ना. 0 0 0. Option C is correct. And if you will check option D, tv1 plus v3. tv1 plus tv3. 1 1 minus 2 plus 0 3 minus 3. And it comes to be 0 4 minus 5. So clearly it is not equal to tv2 na. So option D is discarded. And answer is option C. Now is it clear?
यहाँ पे 1 4 minus 5 आएगा. 0 4 5 0 4 लास्ट लास्ट लास्ट.
हाँ ठीक है
0 4 1 4 minus 5.
समझ. This is a linear transformation defined by t x1, x2, x3 x1 plus 3x2 plus 2x3, 3x1 plus 4x2 plus x3, 2x1 plus x2 minus x3. And I need to find dimension of range space of T square. Option A, 0, 1, 2, 3. Try this.
It is 2. C option.
Correct. So firstly, you can directly see the matrix representation of T with respect to basis, and basis will be of R cube only, standard basis. So coefficients of x1 will come 1, 3, 2, 3, 4, 1, 2, 1 and minus 1. And I'm asked to find dimension of range space of T square. Simply multiply this.
It is 14, 17, 3, 17, 26, 9, 396.
Now I know that dimension of range space of T square is rank of T square, na? Rank of T square means number of non-zero rows. So I can clearly see that if I add R1 and R3, I am getting second row na? Hai na? Or you can apply the row operation also. R3 tends to R3 minus R2 plus R1. Then you will get 14, 17, 0, 17, 26, 0, 3, 9, 0. This means there are two non-zero rows. So this is 2. Your approach was same?
Yes, ma'am. It was same.
Okay. if the nullity of the matrix K1 1 1 minus 1 1 2 minus 2 4 is 1, then the value of K is.
It's option B. A is 0.
What is your approach?
Elementary row transformation. I made the values below first column. I make them 0 by row transformation.
Mm. Like this?
Yes, ma'am.
So K minus K minus 1, and here minus 2K minus 2, K minus 1, 4K minus 2. Now you can apply R3 tends to R3 minus R2.
But if I just make them second and third rows equal, if both of them become equal, then one will be discarded. So 1 plus, this is only possible when K is 0.
So मतलब मेरा टारगेट ये है कि नलिटी मेरी 1 रहे.
बनाए रहे. Nullity 1 means one row should be 0. So if I make second and third row same, or to make them same, my K should be 0.
K should be 0. If K is 0, I mean here it will be better now if I use the definition of null space of T first, because nullity is given na as 1. So if I use the definition, then my matrix is K1 1 1 minus 1 1 2 minus 2 4 xyz equal to 0 0 0, because it is like this only, na, tx equal to 0. Now from here, I need to find the value of k. मतलब जो आंसर है ना वो k इक्वल टू -1 दिया हुआ है, k इक्वल टू -1। एक बार ये वाला करें जो हम कर रहे थे, R3 - R2 अगर करूँ तो k - 1 प्लस k मुझे तो लेकिन इसके नीचे वाली 0 बनानी है ना, इसके नीचे वाली 0 कैसे बनाएंगे? मतलब जो बुक में अप्रोच करी हुई है उन्होंने क्या करा, उन्होंने यहाँ से
तो है कि सेकंड रो में अगर k -1 रखते हैं तो सेकंड रो पूरी 0 हो जाएगी।
कहाँ रख रहे हो, यहाँ पे?
सेकंड रो में।
हाँ मतलब इस वाले मैट्रिक्स में रख रहे हो?
हाँ इस वाले में, हाँ अगर k -1 पुट करेंगे देन सेकंड रो विल बिकम 0।
तो ऐसे भी ठीक है,
देन तो फिर दो आंसर्स हो सकते हैं, 0 भी, तो फिर पॉसिबल तो है 0 भी। अगर मैं अगेन अगर इसको k को 0 रखती हूँ,
पर एक
0
सेकेंड ना,
1
सुनो
2
सुनो, अगर ऐसे सोचूं, ये मैंने k इक्वल टू -1 पुट करा, यहाँ से रैंक क्या आएगा? 2 आएगा ना?
ओहो ठीक
है ना?
k
रैंक
को 0 पुट करते हैं तो रैंक 1 हो जाती है, नलिटी 2 हो जाती है बस।
हाँ, रैंक नलिटी थ्योरम लगेगा इसके आगे। तो
k
3
को अगर
-2
0 पुट करते हैं तो रैंक तो ये 1 रो बचेगी, देन रैंक 1 हो जाएगी, नलिटी 2 हो जाएगी, तो
हाँ,
-1 ही
फिर
आएगा।
तो जो क्वेश्चन में गिवन है वही सेटिस्फाई नहीं हुआ, तो k को
-1 ही
-1 ले।
आएगा।
हाँ मतलब कॉम्प्लिकेटेड करने की जरूरत नहीं है, सीधा वैल्यू ये पुट कर करके भी देख सकते हैं, रैंक
देख
चेक कर
सकते
लेंगे और फिर रैंक नलिटी थ्योरम डायरेक्टली।
हैं। यस।
b1 is 1 2 2 -1, b2 is, so these are ordered bases of R square. T is a mapping from R square to R square. This is a linear transformation such that T b1 b2 means matrix representation of T with respect to bases b1 and b2. It is given as 4 2 3 -4, and I need to find T5, 5. Option A is -9, 8. Option B is 9, 8. Option C is -15, -2. Firstly, T12, first element of this basis B1. T12 is 4 2, and T2, -1 is 3 comma minus 4. And I need to find t5 comma 5, means I need to see the image of 5 comma 5 under this matrix representation. And also it is given that this 5 comma 5 is to be written in the linear combination of the given basis b1 na? So from here I will get two equations, alpha plus 2 beta equal to 5 and 2 alpha minus beta equal to 5. So from here if I multiply this by 2, alpha plus 2 beta equal to 5, 4 alpha minus 2 beta equal to 10. 5 alpha equal to 15 means alpha is 3 and beta will be 2 alpha minus 5, 1. This means that 5 comma 5 is, but I need to find t of 5 comma 5 na? So I can apply t on both sides of this equation. So alpha is 3, so that's why it was given the matrix representation. Then only I am able to find this, because linear transformation was not defined. No? So this is 12 plus 3, 15, 3 to the 6 minus 4 2. Answer is option D. So similar to this question, there was one question asked in T was a mapping from R square to R square linear transformation such that T1 comma 2 is equals to 2 comma 3 and T0 comma 1 is equals to 1 comma 4, and you need to find T5 comma 6. Try this.
Not getting, ma'am.
This was the same approach, na? So you can see that 1, 2 and 0, 1 forms a basis for R square because they are Li, na? I have told you that you can check Li by finding the determinant. If determinant is non-zero, then it is Li and it will also span the complete R square. And I need to find the image of 5, 6. So 5, 6 can be written as linear combination of the elements of basis 1, 2 plus 0, 1. So again, here you will get two equations. One will be alpha plus 0 beta. Then alpha is directly 5. 2 alpha plus beta equal to 6. Alpha is 5. Then beta will be 6 minus 2 alpha. And I need to find image of t, image of 5, 6. So I will apply linear transformation on both the sides. So alpha was 5. T1, 2. It is 2, 3. And T01 was 1, 4. So it will be 10 minus 4, 6. 15 minus 16 minus 1. So answer will be option A. Now is it clear?
Yes, ma'am.
U is equals to ABC such that A plus 2B minus 3C is 0. 2A plus 5B plus 2C equal to 0. 3A minus B minus 4C equal to 0. This is a subset of R cube. Let A is equals to 1, 2, 3, 2, 5 minus 1, 3 minus 3, 2 minus 4. Then you need to find dimension of U and rank of A. Try this.
It's D option.
Why?
See, there is 3 linearly independent rows of A. So rank is 3. Rank of A is 3.
Rank is 3, or I have told you one more way na, in system of linear equations, that if determinant of A is non-zero, then rank is full.
Rank is full. Yes.
So rank is 3. And after that, what about dimension of U?
Dimension of U is, it is also 3, but it is homogeneous, so there is only one solution, no? 0, 0, 0.
Dimension of U. Write this as a matrix.
That is the same matrix.
And all these conditions are equal to 0, so you can relate like this, that the linear transformation was like this only, and we are putting each and every vector, or I can say each and every entry equal to 0, means we are talking about nullity.
Nullity. So nullity is 0.
So nullity.
So dimension of U is 3.
नहीं, nullity of A ही हो गया ना, क्योंकि ये तो A मैट्रिक्स ही है, ठीक है. And by rank nullity theorem, nullity of A will be dimension of R cube na, minus rank of A, 0.
Okay.
Means basically this मतलब थोड़ा सा कॉम्प्लिकेटेड बना के कर दिया क्वेश्चन, कि समझना ही मेन टास्क था इसमें. Dimension of U was nullity of A only. Zero. So answer is option A.
A.